Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, this is lesson 17, equations involving factored expressions. Okay, so starting out with a classwork exercise, pause the video, see if you can do this page, come back and check, see how you did. All right, so here we go. Solve for each equation for x. So I'm just going to simply add 10 to both sides on this one, and I'm going to get x equals 10. So if I think of my solution set notation, it's the set including 10. All right, part B. First, I need to get rid of this 20. Get the constant over on the other side. Now I have x divided by 2 equals negative 20. And to get rid of division, you multiply by the denominator. They cancel, and you get x equals negative 20 times 2 is negative 40. So my solution set is negative 40. Okay, quick review here. Okay, part C says demanding Dwight. I wonder if he's Dwight Schrute. Insists that you give him two solutions to the following equation. X minus 10, this equation, or expression, times x over 2 plus 20, this expression, multiplied together equals 0. Can you provide him with two solutions? Well, it would be these two answers here, negative 40 and 10. Because that's the zero product property, and that just basically says that if a times b equals 0, then a equals 0, b equals 0, or a and b equals 0. Because 0 times anything is 0. So 10 makes this 0, and negative 40 makes this 0. There you go. D. Demanding Dwight now wants 5 solutions to the following equation, and there's 1, 2, 3, 4, 5 expressions. Can you provide him with 5 solutions? Well, what makes this one 0? So you'd say x minus 10 equals 0. Add 10 to both sides, so x equals 10. So there's 1. 2x plus 6 equals 0. Subtract 6. 2x equals negative 6. Divide by 2. X equals negative 3. So x equals 10. X equals negative 3. There's 2 of them. X squared minus 36 equals 0. X squared equals 36, and therefore x equals plus or minus 6. So there's 2 solutions right there. And then we already had this one done from up here. This one is negative 40, just to save time. So there's 1, 2, 3, 4, 5 right there. And putting them in order from least to greatest, it'd be negative 40, negative 6, negative 3, 6, 10. Okay? And I still hadn't done this one, which would be plus or minus the square root of 10. So actually there's 7 solutions. Do you think there might be a 6th solution? And the answer is yes, because, as I said, looking at this portion that I didn't even address, x squared plus 10 equals 0. Oh, wait, there is not, because that's plus sign right there. Okay. Because if I subtract 10 from both sides, I get x squared equals negative 10, and therefore x equals plus or minus the square root of negative 10. Ding, 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 ding. You cannot take the square root of a negative. It is not a real number. So, not if, and I'd say no, not a real solution. There's 2 more solutions, plus or minus square root of negative 10, but they're not real. Okay, page 2 brings us to part E, and it says, consider the equation x minus 4 times x plus 3 equals 0. It says, rewrite the equation as a compound statement. So what they're saying is you have 2 terms being multiplied together and they equal 0. So there's my a times b equals 0. So a is 0, or b is 0, or they both are. So if we were consider this a compound statement, we would say a equals 0 or b equals 0. And in other words, x minus 4 equals 0, or x plus 3 equals 0. Find the two solutions to the equation. I'll just do that right up here. Add 4 to both sides, and I get x equals 4. Subtract 3 from both sides, and I get x equals negative 3. So my solutions are, from least to greatest, negative 3, 4. Okay, example 2, or example 1. Solve 2x squared minus 10x equals 0 for x. Well, the first thing I always like to do is factor. So 2 will go into 10, so I know 2 is a factor. There's an x squared, there's an x, so I know x is a factor. So in other words, if I have a quadratic with no constant term, here's the quadratic term, here's the linear term, no constant, you can factor out a variable. So we have 2x squared divided by 2x is x. We have a minus sign here. 10x divided by 2x is 5 equals 0. So if I do what I did up here and did a compound, it's either 2x equals 0 or x minus 5 equals 0. Divide this by 2, divide this by 2, and I get x equals 0, or add 5. Let me try that again. Thinking one thing, writing something else. Add 5, add 5. These cancel, and I get x equals 5. So my solution set is the solution 0, 5. Okay, example 2. Solve this. Well, whenever you see a parentheses that is the same, x minus 3, x minus 3, see how these two match? That means that we have factored it, and that is one of the terms. The other term is what's outside. So I have an x and a plus 5. So that goes in this parentheses. So if I FOIL this, I would get the same quadratic that this would produce. So it's x plus 5 times x minus 3 equals 0. Okay, that's just doing the distributive property backwards. This is x times this plus 5 times this, giving us that. So now if I set these both equal to 0, we get x plus 5 equals 0, or x minus 3 equals 0. So subtracting 5 here would give us x equals negative 5, and adding 3 here would give us x equals 3. Putting these in set notation, smaller first, increasing to the largest, and there you have it. Okay, and then exercise 2 through 7 says to do just this. So I'm going to speed up the process here. Actually pause the video, try these 3, unpause and check. All right, so I'm going to speed up this. Instead of rewriting all of this, I can just do these in my head. It's pretty simple. So what makes this 0? Negative 1. What makes this 0? Negative 2. So my answers are negative 2 and negative 1. Okay, now when I have this one's a little different. It's got a coefficient in front. So here's what happens. You add the constant over, and you get 3x equals 2, and then you divide by 2, and you divide by 2, and you get x equals, you divide by 3, and you divide by 3, right? This is a 3. 3 divided by 3, and 2 divided by 3 will give me 2/3. So all you're really doing is taking this number and putting it under here and changing the sign. That's the shortcut. All right, so I got 2/3 here, and x equals negative 12 here. So my solution set would be negative 12, 2/3. Okay, and then on to this one, x minus 3. Well, what makes that 0? Well, 3 minus 3 is 0, so x equals 3. So this would be x equals 3, and this would also be x equals 3. So there's only one solution here. It's called a double root, and the answer is 3. Okay, page 3 brings us to 3 more examples. Pause the video, see if you can do these 3. Come back and see how you did. Okay, so I'm going to go through these fairly quickly. When they're already factored out, the answer or the solution is the opposite sign of what's in there if there's no leading coefficient. So x plus 4, x equals negative 4. X minus 6, x equals positive 6. And x minus 10, x would equal positive 10. So my solution set is -4, 6, 10. Okay. This one I have to factor out an x. So I take x out. X squared divided by x is x, minus 6x divided by x is 6 equals 0. This x would equal 0, and this x would equal 6. So my solutions are 0 and 6. And the last one, remember I did an example earlier. This is a factored form. If I put it back together, one of my terms is x minus 5. The other one is x plus 4, the outside piece. This and this put in a parentheses. So when I FOIL these, I would get my original up here. So this would be x equals -4, and this would be x equals +5. So my solution set is -4, 5. Example 3. Consider the equation x minus 2 times 2x minus 3 equals x minus 2 times x plus 5. Lulu chooses to multiply through by 1 over x minus 2 and gets the answer x equals 8. But Poindexter points out that x equals 2 is also an answer, which Lulu missed. What's the problem with Lulu's approach? Question mark. Okay, so if you're watching all of my videos, you would have seen this in video, let's see, this is lesson 17. It was 16, 15, or 14. It was recently. You cannot multiply by 1 over x minus 2 because x minus 2 could equal 0, which means that you would be dividing by 0. So that's why you cannot do this. Okay, x minus 2 equals 0, that would mean x equals 2, and it does right here. So we can't divide by 0. That would give us an undefined term. And that's why we can't. So it says use factoring to solve the original equation for x. Okay. So I'm going to rewrite this. X minus 2 times 2x minus 3 equals x minus 2 times x plus 5. And I'm going to move everything over to one side so that it's set equal to 0. So it's going to be x minus 2, oops, forgot the minus, x minus 2, and 2x minus 3, minus, so if I subtracted x minus 2, it would be over on the other side as minus x minus 2 times x plus 5. Equals 0. So all I did was move this right side over to the other side and made it a minus. So I subtracted these two products. Okay, so now I have an x minus 2 and an x minus 2 and a 2x minus 3 and an x plus 5. So I can rewrite this as x minus 2 as my factor that I factored out of this. Okay, let me change colors here because this might confuse you. Let me erase this piece first. Let me change this to red. So what I'm going to do is take this, 2x minus 3. So x minus 2 times 2x minus 3 would give us this piece here. And then there's a minus sign here. So it's going to be minus, and then 2x minus 2 times x plus 5 gives us x minus 2 plus times x plus 5. So if I just put x plus 5 here, then you see this term. So it would be this times this would give us this piece right here. And this times this would give us this piece here. Okay? So it's just a distributive property, and it still equals 0. Alright, so now I can simplify inside the parentheses. I'll just stay with red here. X minus 2, and I have a 2x minus x, which is 1x. And I have a -3 minus 5, which is minus 8, equals 0. So it was 2x minus x is x. -3 minus 5 is -8. So I have an x minus 2 times an x minus 8 equals 0. So then when I use the zero product property, I'd say x minus 2 equals 0, or x minus 8 equals 0, therefore x would equal 2, or x would equal 8. So my solution is 2 or 8. So Poindexter was correct. Of course, Poindexters are always correct. Alrighty. And Lulu missed the 2. Okay, page 4 brings us to exercises 8 through 11. So again, these are exercises. Pause the video, see if you can do them, and then come back and see how you did. Okay, here we go. It says use factoring to solve this equation. So again, we're going to move everything over to one side, set it equal to 0. So it's going to look like x minus 2 times 2x minus 3 minus x minus 2 times x plus 1 equals 0. Okay. So if I factor out that x minus 2, like we did in that last example, I think it was b, x minus 2, and that would be times 2x minus 3 minus x minus 1. Okay, so I double parenthesis so you see that. So it's x minus 2 times this minus that. So this times this would give me this. Still equals 0. Simplify this, we get x minus 2 times 2x minus x is x. Negative 3 minus a negative 1 is plus 1. Negative 3 plus 1 is negative 2 equals 0. So I get x minus 2 times x minus 2 equals 0. Did I do that correctly? No, I made a mistake. See this x plus 1? That should be a plus right here. That changes this. Okay, so this should be 2x minus x is x. That's correct. But minus 3 minus 1 is minus 4. Now I get x equals 2 or x equals 4. So I have two solutions, 2 and 4. Okay, part 9. Solve each of the following for x. X plus 2 equals 5. Well, that's pretty simple. It's a basic linear. Subtract 2 from both sides and x equals 3. So my solution set just contains the number 3. X squared plus 2x equals 5x. First thing I would do is subtract 5x over from both sides. Subtract 5x, subtract 5x. That'd be x squared. 2x minus 5x is negative 3x equals 0. Factor out an x and I get x times x minus 3 equals 0. X equals 0 or x minus 3 equals 0. Therefore, x equals 0 or x equals 3. And inset notation is the number 0. And what was that? 3. Whoa, 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 what's going on? Okay, 0, comma 3. All right, there we go, 0, comma 3. Number C. Number 9C, part C. All right, first thing I want to do is, this is FOILed. So this side over here would be x plus 2 times 5x minus 20 equals 5 times 5x minus 20. Okay. Move this over to the other side, I would get x minus 2 times 5x minus 20 minus 5 times 5x minus 20 equals 0. Okay, I'm not liking the direction this is going, so I'm going to do something differently. So sorry about this, but that's why we have erasers in math. We don't always get something right exactly the first time, but once I got to that step, I know there's a better way. So I'm just going to subtract 5 times x minus 20 from both sides. And when I do that, I get x times 5x minus 20. 2 minus 5 is negative 3 times 5x minus 20 equals 0. Now I can put my outside term together as x minus 3, and the 5x minus 20 repeating is that wonderful distribution property, and I get this. So this would be x equals 3, and this would be 5x minus 20 equals 0. So if I add 20, I get 5x equals 20, and divide by 5, I get x equals 4. So my two solutions are 3 and 4. Okay, number 10 says to verify. Verify that a minus 5 times a plus 5 equals a squared plus 25. Or minus 25, I mean. So I'm going to FOIL. A times a is a squared. Outer, a times 5 is plus 5a. Inner is negative 5 times a, which is minus 5a. And negative times a positive is negative. I don't know why I was writing a positive. It is negative, and 5 times 5 is 25. And that has to equal a squared minus 25. Well, I have a middle term. 5a minus 5a goes away. They cancel each other out, and I'm left with a squared minus 25 equals a squared minus 25. So there's our verification. B, verify this times this equals that. Okay, again, FOILing. X times x is x squared. X times 88 is plus 88x. I'll color code this one. Inner is this times this, which is negative 88 times x, or negative 88x. And then finally, last is a negative times a negative, which is, or negative times a positive, which is negative. And 88 times 88, let's just leave it as 88 squared instead of using our calculator, because they didn't square it over here. And that has to equal x squared minus 88 squared. Well, we have middle terms that go bye-bye, and we end up with x squared minus 88 squared equals x squared minus 88 squared. Verify. Okay, page 5 brings us to part C, more verifications. It says verify a squared minus b squared equals a minus b times a plus b. Well, a squared minus b squared equals, and we're going to FOIL again, and I will color code it again, a times a squared. Outer, a times b plus a b. Inner, negative b times a, negative a b. And finally, last, negative times a positive is negative, b times b is b squared. My middle term are opposites and go away, leaving us with a squared, minus b squared equals a squared. This cancels, minus b squared. Verify. Okay, next problem. D. Solve for x. X squared minus 9 equals 5 times x minus 3. Okay. Let's see. X squared minus 9. I could distribute, move everything over, blah, blah, blah. Let's try that. So this would be x squared minus 9 equals 5 times x is 5x. 5 times 3 is 15. Positive times a negative is negative. So I have x squared minus 9 equals 5x minus 15. Subtract 5x, add 15. Subtract 5x, add 15. And I get x squared minus 5x. Negative 9 plus 15 is plus 6 equals 0. X, factors of 6 are 3 and 2. Both negative gives me a negative middle term, and a negative times a negative is positive gives me the middle term, or the end term, as the correct. 3 times 2 is 6. So this is x equals 3 or x equals 2. So my solution set is 2, 3. Okay. Last one. E. Solve for w. W plus 2 times w minus 5 equals w squared minus 4. So I'd FOIL this, and I'd get w squared. Outer is minus 5w, inner is plus 2w, and last is minus 10 equals w squared minus 4. Well, when you have a w squared here and a w squared here, and you subtract them, they cancel. If I add 4 over here, I get negative 5w plus 2w. Now let's combine like terms. Negative 5 plus 2 is negative 3w. And if I add 4 to negative 10, it's negative 6 equals 0. I can factor out a 3, or a negative 3, and leave me with w plus 2 equals 0. So w equals negative 2. And there you have it. Part number 11 says, a string 60 inches long is to be laid on a tabletop to make a rectangle of perimeter 60 inches. So I always like to draw a diagram. So if I draw a rectangle with a perimeter of 60 inches, and I'll just say P equals 60 inches, write the width of the rectangle as 15 plus x inches. So this is 15 plus x. What is the expression for its length? L. Okay. Write an expression for its length. A string 60 inches long is to be laid out on a tabletop to make a rectangle. Perimeter 60. Write the width of the rectangle as 15 plus x inches. What is the expression for its length? Okay, so we want to start this out with our perimeter equation. P equals 2L plus 2W. Okay. Substitute in our givens. 60 is our perimeter, equals 2L plus 2 times our width, which was 15 plus x. Okay, and then when I distribute that, I get 60 equals 2L plus 30 plus 2x. Actually, let's just divide by 2 here. If I divide both sides by 2, then I'd get 30 equals, because there's a 2 factor here and a 2 factor over here, 30 equals L plus 15 plus x. That cleans it up quicker. So subtract 15 plus x from both sides. And that is going to give me 30 minus 15, which is 15 plus x equals L. Oops, careful. Subtract 15 plus x like so, and that would be 30 minus 15 minus x, distributing our negative. So that would give me 15. 30 minus 15 minus x. So it would be 30 minus 15 minus x equals L, which would give me L equals 15 minus x. Okay, so there it is. L is 15 minus x. So what is the expression of its length? 15 minus x. What is an expression for its area? Well, area equals length times width. Let me change colors. Let's do green this time and continue with my green pen. Area equals length times width. Well, the length is area equals 15 minus x times width, which is 15 plus x. So when I distribute this, or FOIL it, 15 times 15 is 225. My middle terms cancel, plus 15x minus 15x, and then it's going to be minus x times x is x squared. X squared. So it's 225 minus x squared if you FOIL it, but this would be an acceptable solution. What value of x gives an area of the largest possible value? Okay, so as x increases from 0 to 15, the area decreases. So the value of x that gives an area of the largest possible value would be 0, right? If x was 1, it'd be 225 minus 1, which is 224. If x was 2, 225 minus 2 squared, which is 4, is 221. So the area is decreasing. So the largest possible area would be 225 square inches, and that is when x equals 0. So when x equals 0, the width is 15 plus 0, and the length is 15 plus 0, and that would be a square of area. I'm sorry, a square of length 15 by 15. So what value of x gives an area of the largest possible value? Value x equals 0. And then it says, describe the shape of the rectangle for this special value of x. Well, when x is 0, it's a 15 by 15 square. There's the description of the shape. Okay. Okay, page 6 brings us to the end of lesson 17. Review the lesson summary, the zero product property, and go to your problem set.